Alright, Chapter 2, Basic Heat Treatment. As steel workers, we are interested in heat treatment of the metals because we know that the effects of the heat treatment produced by welding, cutting as on a metal. We also need to know that the methods of restore the metal original condition process for the heat treating is method of which metal are heated and cooled in a series of specific operations never to allow the metal to reach molten state. The purpose of the heat treating is to make the metal more than usually by changing and restoring mechanical properties. Heat treating we can make the metal harder, stronger, more resistant to impact. Also, heating treating can make it a metal softer, more ductile. One of the disadvantages of the non-heat treatment procedure can reduce all of the characteristics. One operation, some properties are improved at the expense of the others. For example, the hardening of metal may make it brittle. Heat treating theory. First step of the heat treating process are similar because they involve the heating and cooling of the metal with the difference of the heating temperatures and the cooling rates and even the final result. Usual methods of the heat treating ferrous metal with the metals with iron or annealing, normalized hardening, tempering non-ferrous metal with be annealed, never tempered, normalized, or case hardened. Successful heat treatment requires a closed cut overall effective of the heating cooling over the metal with the control is possible only when the proper equipment is available. The furnace must be proper size and type of control with the temperature of the kept and prescribed limits for the each operation. Each of the furnace the atmosphere effect for the condition of the metal being heat treated. Furnace atmosphere consists of the gases circulate through the heating chamber surrounded with the metal with the being heat of the electronic furnace. The atmosphere, the air, either the air, the controlled mixture of the gases. Fuel-fired furnace atmosphere is a mixture of the gases comes with a combination of the air and the gases released from the fuel during combustion. These gases contain various proportions of the carbon monoxide, carbon dioxide, hydrogen, nitrogen, oxygen, white water vapor, leather, hydrocarbon, and fuel-fired furnaces can provide three distinct atmospherics in varying proportions of air and fuel. They are called oxidizing, reducing, and neutral. Stage of the heat treatment. The heat treating accomplished in three major stages. Stage 1, heating the metal slowly to ensure the uniform temperature. Stage 2, soaking or holding the metal at a given temperature for a given time, cooling the metal in a room temperature. Stage 3 is cooling the metal to a room temperature. Heating stage. The primary objective of the heating stage is to maintain uniform temperature. If uneven heating occurs, one section of the part will expand faster than another, result of distortion, cracking, and uniform temperature attained by slower heating. Heating rate depends on several factors. Other important factor: heat conductivity of metal with a high conductivity heats to the faster rate, one of the lower conductivity. Although the combination metal determines the rate of which may be heated. The heating rate of the hardened tool of the parts may be slower, unstressed, untreated. The metal finally size of the cross section figures into the heating rate. Parts with a larger cross section require slower heating rates to allow for the interior temperature for the remaining close to the surface temperature that prevents warping or cracking. Parts that are uneven the cross section experience uneven heating. However, such parts are less apt to be cracked, excessively warped when heating rate is kept low. Soaking stage. After the metal is heated with the proper temperature, is held with the temperature until the desired internal structure changes takes place. This process is called soaking. The length of the time held at the proper temperature is called soaking period. Soaking period depends on the chemical analysis of the metal, with the mass of the properties of the steel parts of the uneven cross section. The soaking period is determined by the largest section. During the soaking stage, the temperature of the metal is rarely brought from room temperature to the final temperature of the one operation. Instead, the steel is slowly heated to a temperature just below the point at which it changes takes place, and then it is held at the temperature until the heat is equalized throughout the metal. While this process preheating, following with the preheat, the metal is quickly heated with the final required temperature. When a part with the intricate design, it may have the preheated more temperature to prevent cracking, excessive warping. For example, the assume with the intricate part needs to be heated at 1500 degrees. Hardening part can be slowly heated with 600 degrees Fahrenheit. Soaked with the temperature, heat slowly at 1200 degrees Fahrenheit, and soaked with the temperature following with the final preheat. The part should then be heated quickly to the hardened temperature of 1500 degrees Fahrenheit. Note: non-ferrous metals are seldom preheated because they usually do not require preheating. Can cause increased grain size in these metals. Cooling stages. After metal has been soaked, it must be returned to the room temperature, complete with the heating process. To cool the metal, you can place it in direct contact with a cooling medium composed of gas, liquid, solid combination of these. The rate at which the metal is cooled depends on the metal, the property of the desire. The rate of cooling depends on the medium. Therefore, the choice of the cooled medium has important influence property desired. Quenching is produced when cooling metal is rapidly in oil, water, brine, some other medium. Because most metals are cooled rapidly during hardening process. Quenching is usually associated with the hardening. However, the quenching does not always result in increased hardness. For example, to anneal copper, usually quench it in water. Other materials such as air-hardened steels are cooled at a relatively slow rate and harden. Some metals crack easily, warp during quenching. Some others suffer no ill effects. Therefore, quenching medium has been chosen to the metal brine or water. Use metals to require a rapid cooling rate, and oil mixture is more suitable for metals that need a slower rate of cooling. Generally, carbon steels are water hardened, and alloy steels are oil hardened. Non-ferrous metals are normally quenched in water. Heating coolers, heat coolers for steel. You're probably familiar with the term red hot as applied to the steel, but actually steel takes the several colors and shades of the time, turns it dull red until the reach of the white heat. These colors are corresponding with the temperatures listed in Table 2.1. During the hardening, normalizing, and annealing steel heated with the various temperatures of the produced color changes. By observing these changes, you can determine the temperature of the steel. For example, to assume with the most hardened steel part at 1500 degrees heat with the part slowly, evenly while watching it closely for any change in colors. And once the steel begins to turn red, carefully note each of the changes in shade. Continue the even heating until the steel is bright red and the quench depends. Success heat treating operation depends largely on the judgment accuracy of which heat identify each color with the corresponding temperature. For the say with Table 2.1, you see the close observation necessary. You must be able to tell the difference between faint red, blood red, between dark cherry and medium cherry. You had difficulty with the conception. Medium cherry may be different from that of the person prepared the table. For actually with heating treating operation, you should get a chart showing the actual colors of the steel various temperatures. Types of heat treatment. The four basic types of the heat treatment are used today with annealing, normalizing, hardening, and tampering. Techniques used in each process, how they relate. Steelworkers given in the following paragraphs. Annealing. In general, the annealing, opposite hardening, the annealing metals to relieve internal stress, soften them, making them more ductile, refine with grain structure. Annealing consists of having the metal to a specific temperature, holding it in temperature for a set length of time, then cooling the metal to a room temperature. Cooling method depends on the metal and the proper desire. Some of the metals of the furnace colored, others colored by burying them in ash, lime, or insulating materials. Welding procedure with a hot molten metal next to the other room temperature. As the weld cools, internal structures occur along hardened spots. Brittleness. Welding can actually weaken the metal. Annealing is just one of the methods correcting these problems. Alright, so we have table heat, one color steel, red, fine red, faint red, visible dark, 75 to 7,500 degrees Fahrenheit, faint red, 910, blood red, 1050, dark red, 1075, medium cherry, 1250, cherry full red, 1375, bright red, 1550, salmon, 1650, orange, 1725, lemon, 1825, light yellow, 1975, white 2200, dazzling white 2350. Alright, table 2, approximate soaking periods, hardening and annealing, normal strength. Thickness is in inches up to 1 inch, 3/4 of an hour of soaking time in a half hour. 1 to 2, 1 1/4, 1 1/2, 2 to 3, 1 3/4, 3/4, 3/4, 2 1/4, 1. 4 to 5, 2 3/4, 1, 5 to 8, 3.5 to 1.5. Alright, various metals. To produce maximum softness and steel, you heat the metal with the proper temperature, soak it, and let it cool very slowly. The cooling is done burying in the hot part of the insulating material, shutting off of the furnace, allowing the furnace and the part to cool together. The soaking period depends on both the mass of the part, the type of the metal, with the approximate soaking period of the annealing steel and or given in the table. Steel with extremely low carbon content requires highest annealing temperature. With the carbon content increases, the annealing temperature decreases. Non-ferrous metal with the copper becomes hard and brittle with a mechanically worked. However, that may be softened again with annealing. Annealing temperature for copper is between 700 and 900 degrees Fahrenheit. Copper made with a cooled and rapidly, slowly sensible. The cooling rate has no effect with the heating treatment. The one drawback experienced with annealing copper is phenomenon called shortness. At about 900 degrees Fahrenheit, copper loses for the tensile strength if not properly supported with the fracture. Aluminum reacts similar to copper when heating, treating with the other character of the hot shortness. A number of aluminum alloys exist, and each requires special heat treatment to produce their best properties. Normalizing on the type of the heat treatment applicable to ferrous metals, only with the difference for the annealing is for the metal heated with a high temperature when the remove of the furnace air from air cooling. The purpose of the normalizing to remove the internal stress of the induced through the heat treating, welding, casting, forging, forming, machining, stressing, non-controlled leads, material failure, but therefore made by hardened steel. But you should have normally at first ensure for the maximum desirable results, usually low carbon steel. Not required normalizing, however, if the steel is normalized, no harmful effects result of the casting, usually the nail rather than normalized. However, some of the casting requires normal treatment. The table 32 show the approximate soaking period with the normalizing steel. Note the soaking time varies from the thickness of the metal. Normalized heats are harder than stronger than the anneal steels over the normalized condition. Steel with a much for the touch over any other structural condition. Parts subject to the impact loads require maximum toughness, resistant external stress, and usually normalizing mass of the metal has an influence on cooling rate on the result of the structure of the piece will cool faster and harder than any of the normalizing thick ones. Annealing of the furnace cooling, the hardness of the two are about the same. Hardening treatment of most steels consists of the heating of the steel with a set temperature for the cooling and it rapidly and plunging it into oil, water, or brine. Most steels require rapid cooling, quenching of their hardening, but a few can be air cooled with the same results. Hardening increases the hardness and strength of the steel, makes it less ductile. Generally, the harder the steel, the more brittle it becomes. To remove some of the brittleness, you should temper the steel after hardening. Most non-ferrous metals are hardened. Their strength increases with the controlled heating and rapid cooling. In this case, the process is called heat treatment rather than hardening. Hardening steels you can cool rapidly after thoroughly soaking them in the temperature, and it's likely above the critical point. Approximately soaking periods hardened steel that are listed in Table 2. Additional alloy steel decreases the cooling rate required to produce hardness. Increasing cooling rate in the advance since the lesson of the danger over the cracking and warping. Pure iron, wrought iron, and extremely low carbon steels have very little hardened properties and difficulty hardened by heat treatment. The cast iron is limited to the capabilities of hardening. When you cool cast iron rapidly, it forms a white iron, which is hard and brittle. When you cool it slowly, it forms a gray iron, which is soft and brittle under impact. And plain carbon steel with the maximum hardness of the attained with the heat treatment, it depends mostly entirely with the carbon content of the steel. With the carbon content increases the hardening ability with the steel increases. However, the capability of hardening will increase with the carbon content continuously with a certain point. In practice of 0.8% carbon required maximum hardness when increase the carbon content between 0.8% and no increases hardness, but there is an increase in wear resistance. The increase of the wear resistance due to the formation of substance called hard cementite. When you allow steel to increase the hardness, allows to make carbon more effective. With the increase in the hardness and strength may come with the carbon content required to produce the maximum hardness. It's lower than it is for plain carbon steel. Usually, alloy steels are superior to carbon steel. Carbon steels are usually quenched with the brine, with the water, but the alloy steels are generally quenched with the oil. With the hardened carbon steels, remember that you must cool the steel with below 1,000 degrees Fahrenheit, less than 1 second. You would add an alloy steel with the time limit about with the temperature drop to below 1,000 degrees Fahrenheit. Increase above the 1 second limit of the slower quenching medium can be produced with desired hardness. Quenching produces an extremely high internal stress, and the steel will relieve the temperature of the steel just before it becomes cold. Part is removed with the quenching bath with a temperature of about 200 degrees Fahrenheit. Allow the air cool with the temperature ranging from 200 degrees Fahrenheit down to room temperature is called cracking range. You don't want steel to pass through. But in the following paragraphs, we discover the different methods of hardening in the commercial use. To conceive these, we use the rapid surface hardening with a compound called case. They can be ordered through a Navy supply system. Information used for the case is located in the Welding Materials Handbook, page 433. Case hardening. Case hardening produces hardware resistant surfaces and cover over strong, tough core with the principle of the forms of the case hardening and with the carbonizing cyaniding and nitriding. Only fierce metals are cased and hardened. Case hardened idle parts of the required with the wear resistant surface must be tough enough to internally withstand with a heavy loading steels base suited with the case hardened with low carbon and low alloy series. High carbon steels are case hardened. The hardness penetrates the core of the cover of the brittleness, and in the case of the hardening, you change the surface of the metal chemically with introducing high carbide nitrate content. The core remains chemically unaffected when the heat treated with a high carbon surface responds with the hardening and the core toughens. Carbonizing with the case of hardening profit the carbon is added to the surface of the low carbon steel with the result of the carbonized steel that has a high carbon surface, the low carbon interior of the carbonized steel with the heat treated. In this case, it becomes the hardened end core remains soft and tough. Two methods use the carbonizing steel. One method is the heating of the steel in the furnace and containing with a carbon monoxide atmosphere. The other method is steel placed in a container packed with charcoal or some other carbon-rich material, then heated in the furnace. The two cool parts will leave the container with the furnace to cool, with the remove of the lead, with the air cool, with the both cave of the parts becoming annealed during the slow cooling. Tip of the carbon penetration depends on the length of the soaking period. Within 2 days, method of carbonizing almost successfully done by gas atmosphere cyanide. The process type of the case for the hardening and fast sufficient with the preheated steel dipped in the heated cyanide bath, allowing it to soak with the upon removal of the quench and then rinsed with the removal of any residual cyanide. The process produces a thin hardened shell with a harder than one produced by carbonizing. It can be completed in 20 to 30 minutes, vice versa, several hours. Major drawbacks is cyanide salts are highly deadly poisonous. Nitridizing. The case hardening method produces hard surface with any hardening process. Any difference with the other methods that individual parts have then heat treated tempered for nitridizing. These parts are heated with the furnace and have the ammonia gas atmosphere. No quenching is required, so that there are no worry about warping or types of distortion in the process due to the case hardened items such as gears, cylinders, sleeves, camshafts, other engine parts. You need to wear resistant operate high heat areas. Flame hardening. Flame hardening is another procedure for the UV of the hardened surface metal parts which UV the axis settling flame in the thin layer of the surface of the part. Rapidly heated, critical temperature, but then immediately quenched for the combination with the water spray with the cold base metal. The process produces the thin hardened surface at the same time, and the internal parts will retain the original properties. Whether the process is manual or mechanical, close watch must be maintained with the torch heats of the metal rapidly, and the temperature is usually determined visually. Flame hardening may either be manually or automatic. Automatic equipment produces the uniform results and more desirable than automatic. Machines have various travel speeds, can be adapted to various sizes and shape. The size and shape of the torch depends on the cut and pour. Torch consists of the mixing head with a tray extension tube with a 90-degree extension head and an adjustable yoke and water-cooled tip, particularly any shape, size, flame hardening, and tip that is available to Tube 1. Tube 1 shows the progressive hardening and the torch tip with the heating holes and the quenching holes. Tips produced can be with the hardening flat with the rounds, gears, cam, the cylinders for the other regular irregular shapes. Hardening localized areas should be heated with the metal with a standardized handheld welding torch. Adjust the torch flame to neutral, chapter 4 with a normal heating. However, the corners of the groove with use slightly oxidizing flame to keep the torch from sputtering. You also should particularly with the ground against the overheating of the combers and groovers. Combers and groove. The dark streak appeared with the metal with the surface of the sign with the overheating you need to increase the distance between the flame and the metal. For best results, hold the torch within the tip of the inner cone with about an eighth of an inch from the surface of the direct with the flame and a right angle with the metal. Sometimes the necessary change with the angle will obtain with a better result. However, they rarely find the deviation of more than 30 degrees to regulate the speed of the torch travel according with the type of the metal mass shape of the part and darkness of the hardness desired. In addition, you must select the steel according to the property desired. Select carbon steel within the surface of the hardened primary factor for the alloying steel when the physical properties of the core are also factors. Plain carbon steel should contain more than 0.35% carbon. Good results in flaming hardened. Water quenching effective with a carbon range of 40 tenths to 7 tenths of a percent. Parts of carbon content more than 7 tenths of a percent are likely to surface the crack, and unless hardening, heating, and quenching rate quick are carefully controlled. Surface hardening and flame hardened section equally section of the hardened furnace fading. Heating and the quenching decrease the hardness between the case and the core is gradually. Since the core is not effective with the flame hardening, the little danger of the swelling and flaking while the part is in useless flame. Hardening produces the hard case a highly resistant to wear with the core retention aids original properties. Flame hardening can be divided in 5 general methods: stationary, circular, band, progressive, straight line, progressive, spiral, band, progress, circle, band, spanning. Alright, 2.2 shows the progressive hardening, direction of travel, the flames, the quenching, and water, and the hardening zone. Stationary method. In this method, the torch and the metal are both held. Stationary circular band and progressive method. The method view the hardening outside of the surface of the round section. It's usually object to rotate in the front with a stationary torch surface speed of 3 to 12 inches per minute. Heating and quenching are done progressively with the part rotate. Therefore, when the part is completed, one rotation hardening it into the circle of the part. With the hardened band depends upon the width of the torch, shape of the hardened, the full length of the long section. You move the torch of the repeat the process over and over until the part is completely hardened. Each pass or path over the torch should overlap the previous one, preventing soft spots. Straight line progressive method. While the straight line progressive method, the torch travels along the surface of the treating the strip that is above the same width of the torch tip. Harden the wider area of the move of the torch. Repeat the process is an example of the progressive hardening. Similar spiral band progressive method. The technique with the cylindrical parts of the mounted between the lathe centers and the torch adjustable holder mounted with the lathe carriage. As parts rotate, the torch moves parallel to the surface of the part and travel with a synchronized with the part's rotary motion, produce a continuous band of hardness. Heating and quenching occur at the same time, and the number of the torches required depending on the diameter of the part, but seldom are more than 2 torches used. Circular banding spinning method. The circular band spinning method provides the best results of hardening cylindrical parts of small medium diameters. This part with the mounted with the lathe with the percentage of the turn at the high rate with the spar. Speed of pass, high rate speed past the station torch. Enough torch is placed side by side to heat the entire part of the part can be quenched by water flowing in the torch shape with a separate operation. When you perform heating and quenching separate operations, the tips of the water cooled internally, but no water sprays or surface of part. Flame hardening, you follow the same of the safety precautions appeal to apply to welding. See Chapter 3. Particular guard against holding the flame too close to the surface of overheating metal within judging of the temperature of the metal. Remember that the flame makes the metal appear colder than it actually is. Tempering. Temporary after hard treatment is applied with the shield with the offer harder than even the no brittle most and it's too brittle for the most of the practical uses. Also, the severe internal stress is set up during the rapid cooling from the hardening temperature with the relief of the internal stress to reduce the brittleness. You should temper the steel after hardening. Tempering consists of heating the steel to a specific temperature and below the hardening temperature, holding the temperature for the required length of time, then cooling it using instill air with the resultant strength of the hardness ductility dependent on the temperature of the tube with which the steel is heated during the temperature process. Purpose of tempering to reduce the brittleness and part of the hardening and produce the definite physical property within the steel. The tempering allows valves to never proceed with the hardening operation besides reduction, brittleness, tempering, softness of the steel. Some avoidable amount of the hardness of the lava depends on the temperature of the steel that heated during the tempering process. That is true with all the steels except for the high-speed steel, with the tempering increase the hardness of the high-speed steel. Tempering is always conducive with the temperature below the low critical point of the steel. In the respect of the tempering differs with the annealing and normalizing hardening, in which the temperatures are above the upper critical point. Hardening steel is reheated with the temperature begins at 212 degrees Fahrenheit. With the temperature increase the low critical point by selecting a different tempering temperature. You can determine the result of the hardness and strength. Minimum tempering should be 1 hour if the part is more than 1 inch thick. We can increase the time by 1 hour for each of the additional inches thick. But normally, with the rate of the cooling for the tempering temperature for the no effect with the steel parts usually cooler than the steel after being moved for the remove of the temperature furnace. However, there are a few types of steel that may quench for the temperature tempering temperature that prevent brittleness. Blue brittle steels can become brittle if heated with a certain temperature of the range to allow for the cool slowly. Some of the nickel chromium steels are subject to the tempered brittleness. Steel may be tempered after the normalized, providing there is any hardness temperature for the needle steel that is impossible to temper. Tempering relieves the quenching of the stresses reduce the hardness and brittleness. The actual the tensile strength of the hardened steel will may increase as steel is tempered to the temperature of about 450 degrees above the temperature and stuff with an degree increase. Tempering increases the softness, ductility, malleability with impact resistance, although again high-speed steel with the exemption of the rule. High-speed steel increases the hardness of the temperature provided with the high temperature about 1550 degrees Fahrenheit. Remember, all steel should be removed from the quenching of the bath of temperature before with a completely wide cold. So they temporarily correctly resolve the quick failure of the hardened part. Permanent steel magnets are made with a special alloy that are heated to treat with the hardening and tempering with the hardness and stability with the most important properties within permanent magnet. Magnets are tempered with a minimum temperature of 212 degrees Fahrenheit by placing them in the boiling water for 2 to 4 hours. Because with low tempering temperature, magnets are very hard. Case hardening points should not be tempered for the too high temperature for the magnet may lose some of their hardness. Usually, the temperature range between 212 degrees Fahrenheit to 400 degrees Fahrenheit. Fine enough for the relief of the quenching strength of the metals required with no tempering. The design of the parts help to determine the tempering temperature. Color tempering based on the oxide colors that appear with the surface of the steel with the heated when you slow with the heat with a piece of the polished hardened steel with you can see with the surface of the various colors As the temperature change of the colors indicate that the structural changes are taking place within the metal. Once the power color appears, the part is rapidly quenched to prevent further structural change of the color tempering. The surface of the steel must be smooth, free of oil. Part may be heated by a torture furnace over a hot plate or by radiation. Alright, oxidizing color tempering steels, 2-3, pale yellow, 428 degrees Fahrenheit, straw, 446 degrees Fahrenheit, golden yellow, 469, brown, 491, brown dappled with purple, 509, purple, 531, dark blue, 550, bright blue, 567, pale blue, 610. Color chisel, similar tools must have the card cutting edge with the top of their bodies and heads. Head must be tough enough for the sharing with the truck with a hammer to cut hammer with a hammer. Cutting edge must be more than twice as hard as the head of the zone. Separately, the two must be carefully blended to prevent the line of the demarcation. Then of the color tempering frequently with the chisel, similar tools used in which for the cutting end of the heated by residual heat with the opposite end of the same tool. Hardened temperature cold chisels by the method you heat the tool proper hardening temperature for the quench for the cutting end only, but the chisel up and down in the bath allows you to keep the cutting edge below. Shift the method to air cool for the heating while rapidly with the quenching cutting edge of the result of the tough edge with the fully hardened cutting edge that is properly blended and structural. When cutting edges and the heads removed with the chisel from the bath with the quickly polishing with the cutting edge with the buff stick with the memory. Watch the polish surface as the heat with the opposite end of the feedback with the quenching of the temperature of the hardened end of the increase of the oxide colors appears. Oxide colors in progress of the pale yellow with the straw color end of the blue colors of the assume with the correct shade of the blue appears. Quench of the entire chisel to prevent the further softening or of the cutting edge of the metal is tempered to assume with the proper oxides the colors appears. Quenching merely prevents further temperature without freezing of the process. Final quench has no effect for the body head with the chisel because of the temperature will have dropped below the critical point with the time when the proper oxidized color appears on the cutting edge while completed with above the described process of the chisel with the hardened with the temperature only needs grinding. During the temperature oxide colors with quench the steel vary with the properties desired within the part. Table 2-3 list of the different colors of the corrections applying temperature. See for the colors clearly, they must turn the parts from the side to side, but they have the good lighting. While hardening temperature, hand tempering produces the same result of the furnacing tempering, there's greatly possibility with the air of the slower operation is performed, more accurate the result obtained. Quenching media, the cooling rate of the object depends on many things. The type of the composition, initial temperature of the part of the final property to decide the factor select for the quenching medium, and the quenching medium must cool the metal to a rapid rate, rapidly enough to produce the desired results. Mass effect of the quenching and the mass increase the time required for the complete with the cooling. Also, will increase the even though the parts the same side with the containing hole with the process of the cool more rapidly than solid objects. Composition metal determines the maximum cooling rate possible without danger of the cracking and warping. Critical concerning cool rating in the turn. Influencing the choice of the quenching medium. The cooling rate of the quenching medium varies with the temperature, therefore, will get the uniform results. You must keep the temperature with the prescribed limit of the absorption of the heat. Quenching medium also depends to a large extent of the circulation of the quenching medium of the movement of the part, agitation of the liquid part with the breaks up of the gas forms of the insulating blanket between the part and the liquid. Normally hardening takes place with the quenching of the metal composition. Metal usually determines the type of the quenching used to produce the desired hardness. For example, the shallow hardened low alloy carbon steel requires some of the severe quenching with the deep hardening alloy steel with containing large quantities of the nickel, magnesium, and other elements, therefore shell hardening. Steel usually quenched in water or brine. Deep hardening steel with a quench in oil with some of these types with the necessary with a combination quench, some starting with a brine or water and finishing with an oil in addition producing the desired hardness for the quenching and the must keep cracking, warping, and soft spots of the minimum. The volume of quenching liquid is large enough to absorb all of the heat during the normal quenching operation. Even additional cooling adds more of the metals to quench the liquid appear for the heat of the temperature of the rise of the chaos of the decrease of the cooling rate since quenching liquids are maintained within defined temperature range. The mechanical means they use to keep the temperature prescribed level during the continuous operation. Liquid quenching. The new methods of the use of liquid quenching are the all still bath and flushing quenching. and still bath with the quenching with the cool of the metal of the tank with the liquid. The only movement of the liquid is called the movement of the hot metal so at the beginning of the quench. For flushing, quenching with the liquid is sprayed onto the surface of the end and V with the cavity over the part over the same time with the ensure the uniform cooling. Flushing, quenching is used for the parts of the heavenly recess of the cavity that would not be properly quenched by the ordinary methods to ensure the thorough uniform quenches reduce possibility of the distortion. Quenching liquids may be to maintain uniform temperature satisfactory result, particularly true for oil to keep the liquids at the proper temperature where they are usually circulated through the water and cooled. Coils, self-contained coolers are integral parts of large quenching tanks, and shows an oil and water portable quenching tape. Two portable quenching tape that shown in figure 2-3 with the type that's removed with the needs to various parts of the heating treating shop. With some of the tanks may have one or more compartments. If one or more compartment contains the other water with a portion of liquid right to prevent mixing in the compartment over the drain plug with a screen with the bottom of the catch scale. Other form matter with a mesh skated to hold the parts of portable electrical pump can be attached to the rim of the tank and then circulate with the liquid. Mechanical agitation aids for the uniform cooling. Water can be used with quenching some of the form of the stress seal, but does not produce a good result with the tool with the other yellow with the tool with the water absorb the large quantity of the atmospheric gases when the hot beef of the candles quench. These gases have the tendency to form when the bubbles the surface over the metal with the bubbles tend to collect in holes, recesses, and cause soft spots. Later to leave with the crapping and warping in the warm water with the quench tool should be contained daily more often than is required. Quench tank should be large enough for the whole of the part being treated, but it should have the adequate circulation temperature control. The temperature of the water should not exceed 65 degrees Fahrenheit. When aluminum alloys other non-fierce metal require liquid quenching, you should quench them in with a clean water volume of the water quench tank. They should be large enough to prevent a temperature rise more than 20 degrees Fahrenheit during a single quenching operation. For heavy section part of the temperature rise exceeding the 20 degrees Fahrenheit should be allowed as possible for the product's temperature for the water should be about 65 degrees. Should never exceed 100 degrees Fahrenheit right before the piece enters the liquid. Alright, show the quenching medium cooling rate with water, the flash points, and fire points. And those are for sodium hydrogen, caustic soda, water, 65 degrees, prepared oil, fuel oil, cottonseed oil, neat oil, sperm oil, fish oil, castor oil, machine oil, lard oil, circulated air oil, and still air. Hard brine is dissolved in common rock salt with the water with a mixture produced for the absorption of atmospheric gases for the term reduce the amount of the bubbles dissolved with the brine water wets metal surface and cools it with the more rapid water with the addition of the rapid uniform coloring of the brine removes a large percentage of the scale that may be present. Brine solution should contain 70 to 10% of the weight of the 3/4 of a pound of sulfur each for the gallon of water. The correct temperature range from brine solution 65% to 100% of the low alloy carbon soup that can be quenched in with the brine solution. They have the rapid cooling rate of the brine caused with cracking, stressing with the high carbon and low alloy steel with the uneven cross section because of the corrosive action salt water non-ferrous metals. These metals are not quenched in brine. Oil is used with the quench high speed with the oil hardened steel with the preferred other steels provided with the required hardness that can be obtained, particularly with any type of the quenching is obtainable. Include various animal oils, fish oil, vegetable oil, the mineral oils. The oils classified with the immediate quench and have a slower cooling rate than brine water, faster rate than air. The quenching at the temperature should be kept with a range of 80 degrees Fahrenheit, 150 degrees Fahrenheit, proper average cooling powers. Various quenching oils are given in table 2-4 with the water usually collect with the bottom of the oil tanks, but not harm with a small amount with the large quantities interfere with the quenching operation. For example, the end of the long piece may extend the water at bottom of the tank and the crack with the result of the more rapid cooling than the non-fierce smell with the routinely quenching the oil unless the specification called for the oil quenching. Caustic soda solution with the water. Caustic contains 10% of the caustic soda with the weight with a higher cooling rate with the water. Caustic soda uses only those type of the steel with the required extremely rapid cooling is never to be used with the quench of the non-fierce metals. Warning. Caustic soda requires special handling because of the harmful effects of the skin and clothing. Dry quenching type of the quenching, even the material with other than liquids. Most given the method is used only to slow the rate of the cooling to prevent warping or cracking. Air quenching is used for the cooling some of the highly alloyed steel that used to use steel air of the each shield of the part should be placed in suitable racks so the air can reach all sections of the piece parts cooled with the air circulated air placed in the same manner with the range of the uniform cooling. Compressed air for the concentrate for the cooling of the specific area of the part with the airline. Most of the free moisture prevent cracking with the metal. Although non-ferrous metals are usually quenched in water, please for the too large and too fit the quench for the tank that can be cooled with the forced air draft. However, an air quench should be used non-ferrous metals only when the part when subject to the serve corrosion, condition, the rough strength, and other physical properties can develop by a mild quench. Solids used for the cooling steel parts include the cast and iron chips, lime, sand, ashes. Solids are generally used to slow the rate of cooling. For example, the cast iron parts can be placed in a lime box after welding to prevent cracking and warping. All solids must be free of moisture to prevent uneven cooling. Alright, Chapter 3, Introduction to Welding.